Hello everyone, in this video now we are going to start the next new chapters here, that is the conic section, right? And this is the various conic chapters for your board exam also and your competitive exams also, right? So let us see in this chapters conic section. What is the meaning of conic section, right? So before going to discuss here, let me show you here. It's a basic things. What is the conic section and how it's formed? Then we come to the calculation and their equations and whatever the all. So see here, first of all, cone, right? So here you can see in this case, what is the cone? It's simply three-dimensional geometrical shape, right? That tapers smoothly from flat circular base. So first of all, you can see here we have two cones, right? This is the cone number 1 and this is the cone number 2. Cone number 1 and cone number 2 here we have. So this is known as what? Axis of cone. This is your axis of cone, right? This is the vertex where two cones are meeting over here. This is the vertex angle. Okay, so one is this is your axis and this is your vertex angle, and this is the generator. This line is generator here, slant line, and this is known as the directrix. So what is the directrix? This one here, this one, right? This was circular portion is your directrix here. Now see how the different diagrams formed here. So here you can see the mathematically the surface obtained by generating the generator along the fixed line. So this is the axis, the fixed line, and along which we are rotating it to get a cone. That's why it's named as what? Generator. Semi-vertical angle. This is the semi-vertical. This is full. So but this is semi, right? So now see here how the circles, parabola, ellipse, and hyperbola form. So let us suppose this is the double cone. Here we have, and this is the section, that is the cutting plane, you can say. So if cutting plane is parallel to this directrix here base, so in this case this is forming a circle. You can see here. Okay, this is the circle shape here. This is the parabola. So when this is this is on some angle, right? This is some on angle. This is forming a parabola. This is at an angle, that is ellipse. And here if it is parallel to the axis of the cone, that is forming the hyperbola. Here we have animation. So you can see this animation, right? It is very good, you will understand. So this is here we have the double cone. Okay, this is our vertex point, and this is, you can see your cutting plane, right? So now this time here, this parallel, it's going the circle. Now it becomes ellipse. If further cut, it becomes the parabola, and if it's parallel to it becomes the hyperbola. Got it or not? So hopefully you get the concept. And if it is parallel, this forming the pair of a straight line. So the all cases here, the different diagram is forming, right? See here, you can see once circle is forming, ellipse is forming, then this is parabola, after that hyperbola. So all the figures will be forming here. In this case, this base. Okay now, so hopefully you get the concept here. Then we'll discuss these all the calculations. What is the eccentricity, what is the eccentricity for ellipse, for hyperbola, for parabola. This we'll discuss in the detail here. So this is the main thing that I want to show you, how the circles, ellipse, parabola, and then hyperbola formed. So this way it's formed actually. Okay, let us come to now our discussion. So as I already shown you here, how the circle is formed actually. So this is your double cone, this is the vertex of cone, that you know. This is your cutting plane, right? So this is your cutting plane. This is your cutting plane. Okay, so if cutting plane here cut the double cone, so this here you can see this portion, this forming a circle here, this is forming a circle here. So this circle will be formed in this case. If cutting plane is here in this format, right? So it will be what here? This is your axis. This is your axis of the cone, right? And this angle between them is forming theta. Let us suppose this is your alpha. So this is here forming a what? Ellipse. Then here it is forming the parabola, and here it is forming the your hyperbola. Fine. So these are the things here. So see here, this is your angle. It is supposed to be what? Alpha. Okay. So if you want to understand with the help of angle also, you can know this is your alpha. And suppose this angle, this is your axis, this is your axis. Here we have axis, and this is your cutting plane. So angle between the axis and cutting plane is here. This is supposed to be beta. This is supposed to be beta. So you can say in this case of circle, what is the value of beta here? Beta is equal to 90 degree. Means if the angle between the cutting plane, this is your cutting plane, and axis is 90 degree, then this will form a circle. What is the ellipse? So this angle we have supposed to be alpha, beta, not theta. Suppose let's this is your beta here. This is your beta. So how the ellipse form? So ellipse will form when your beta. This is your beta. So you can see here beta is less than 90 degree. So beta is less than 90 degree, but it will be greater than alpha. That is your the semi-vertex angle. You know alpha I have shown in the animation also. So if this beta is greater than alpha but less than 90 degree, then it will forming what? It will forming here ellipse in this case. Okay. Next, now see, if this is your here, this is your what? This is your angle alpha. That is your semi-vertex angle. And what is this one? So angle between this one here. This is your plane, and this is your axis. So this angle you have taken as what? Beta. This is the angle beta. So if alpha and beta are same, if alpha is equal to beta, then it will form what? Parabola. Got it or not? If alpha and beta are same, then it will form what here? Parabola in this case. And for the hyperbola, so in this case now see, when our alpha is greater than beta, and beta is greater than equal to 0, this is what happened here. Let me draw the axis. This is the axis here. This is the axis. Okay, this is the axis. So this is your angle what? This is your angle alpha. What is this angle? This is the angle alpha here we have. What is the beta? Beta is your this one angle between your this plane and this one. Okay. So angle between, you can see here, this angle is your beta, this one. Okay. So this is your angle over here, beta. So if here, if this beta is smaller than alpha, if alpha is greater, then it will form a what? A hyperbola. So this is the situation here, how hyperbola, parabola, ellipse and circle are forming in the conic section. This is the same visuals here. This is your cutting plane, this is your cutting plane here, this is your cutting plane, right? Then this is your circle. If it is angle is 90 degree, you can see here, if I take this way, this way, this way, this is your axis, this angle is your alpha angle. So angle between them is what? 90 degree. That is beta is equal to 90 degree. So this is forming a circle. When it's forming an ellipse, so you know, in case of ellipse here, if this is beta is less than 90 degree, so you can see here this angle, obviously looking that this is your beta is here less than 90 degree, but it will be greater than alpha. So it is greater than alpha, that is forming it here ellipse, and it is forming hyperbola. So hyperbola forming when beta is greater, when alpha is actually greater than beta, and beta is greater than equal to 0 degree, right? So here alpha is greater actually. You can see if you take here this one, 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 this one. This is your alpha. What is your beta? Beta is the angle between this and this. Don't confuse here, right? So this angle is your beta angle. So beta angle is what here? Angle between this axis and this plane. So this is beta. So as you can see here, this will be greater than this one. So this is actually your what? Hyperbola will forming. So you can see the same relation is here in the 3D format. It's formed. So this is the parabola, ellipse, here circle, ellipse, and hyperbola. Now these all things can be represented using the second degree general equation. So this will discuss in the detail in the JEE video or competitive video, because in NCERT it's not that much discussed or that much used. But let me show you the second degree general equation. Second degree general equation. Second degree general equation. We supposed to be S. So S is equal to actually ax square plus by square plus 2hxy plus 2gx plus 2fy plus c. So this is the second degree general equation, and this is the equation actually that forming all. The single equation represent your parabola also, it will represent your circle also, ellipse also, hyperbola also in different condition by changing the value of a, b, h, g, f and c. How this equation form? This is equally multiplication of two line. If you multiply two linear equation, you will get this type of equation, right? There is one delta is also there, so the value of delta, it depends on the value of delta, right, and the coefficient, right? So what is delta? Delta is equal to ABC, right? ABC plus 2FGH minus AF square minus BG square. So this is the value that we discuss, right? Minus C also, I think. So that we'll discuss. So see here, this is the overview of this coding section, right? Let us now start the calculation hits. So if I discuss what is the conic section, right? What is the conic section actually? So what is the conic section? Conic section, if we want in the calculation. In the conic section here, one have a fixed line. This is your fixed line. This is your fixed line. This fixed line is what? Directrix. Directrix of conic. This is special in directrix. Here we have a fixed point. Here we have what? A fixed point. This fixed point is known as the focus. What is this fixed point known as? Focus. Then here we have the variable. Let us suppose this is the point P, having coordinate is something x, y. This is the variable point, or you can see the locus point. This is your locus point or variable point or moving point, whatever you want to say. This is your that one. So what is the condition? Let us suppose this is your S.P, and the condition is that the ratio of distance from this fixed point to moving point and from moving point to fixed line, this is always constant, right? So what is the point that if you want to add? So locus of point moves in a plane, such that its distance, the ratio such that the ratio of distance from a fixed point to fixed line are always constant. It is always constant, right? So what is the meaning of that? That SP upon PM, this is equal to always constant, and this constant is nothing but your eccentricity. eccentricity of your conic section. This is nothing but your eccentricity of conic section. Fine. So you can see in this diagram it's very better shown that what is the eccentricity of different conics. So circle is also one type of conic, right? So here in the case of circle, right, this is your circle, this is your forming part here, circle. So circle having eccentricity 0. So first, if eccentricity is equal to 0, let's forming part circle will be formed. Second, let us suppose if eccentricity is undefined, it will be the case of pair of a straight line. Pair of a straight line. Okay. Third one, if eccentricity is equal to 1, so this is the case of your parabola. This will form a parabola. Fourth one, if eccentricity is less than 1, this will form an ellipse case. And fifth one, if eccentricity is greater than 1, this is the case of your hyperbola. This is your what? Hyperbola. You can see here, this is your actually what? Ellipse. So ellipse having eccentricity less than 1. So you can take eccentricity 0.5 or 0.7. It will be less than 1. But yes, one more thing, eccentricity cannot be negative, right? It will always be positive because it's the ratio of length. Eccentricity of this parabola eccentricity is always 1. Okay. Eccentricity of hyperbola, it is greater than 1, right? This will be greater than 1, it will be 2, 5 or anything. And this is your pair of a straight line. This is your pair of a straight line. So its eccentricity is what actually? The infinity. This eccentricity is what here? Infinity, because here your directrix and your this focus point line on the same here this way. So this will be actually what? The pair of a straight having eccentricity is infinity. So this is the case here. Circle having 0. Eccentricity of ellipse will be between 0 and 1. For parabola 1. Hyperbola greater than 1. And for eccentricity of line is our infinity. That is the not line. That is the pair of a straight line. This is the pair of a straight line. Okay. So this is the things here. So okay, fine. This is the basic overview of the conic. Now in the next class we'll start with the circle. First we'll discuss circle, after that we will discuss the parabola, then ellipse and then hyperbola. So now one by one we'll discuss all the topic. So thank you for watching this video. Continue, stay tuned for the next topic. So signing off, this is Sachiranjan. Thank you so much.